Hi everyone, I'm going to walk you through setting up Project 1 for CIS 163. Now of course we'll spend some time doing this during lecture or lab in the first week of class, but for those of you who want to get started early or just like having that reminder at home, I hope you find the video helpful. Now notice I'm here and about to log into the EOS lab. You're certainly welcome to work on these assignments on any machine you like, but realize that we can only logistically support the EOS and Arch lab. There's just not a reasonable way for us to be familiar enough with every student's individual machine to be able to help you debug that. So if everything works nicely on your machine, by all means use that. But if you run into problems and you're not really getting a quick resolution, then you just have to fall back to our supported infrastructure here in EOS and Arch. So I'll start by logging in here. And then I'm going to log into the EOS RDP. And by going to the RDP link here, I will get a GUI environment. It'll look as if I were sitting right at an EOS machine in the lab. If I went instead to the SSH link here, then I would have a text-only window. And that's not going to work because I'm going to want to run an IDE. So I'll go to that RDP. And now it does look literally as if I'm sitting in the EOS lab. And I'll have to put my name and password in again. Now the first thing I'll do is launch a web browser and go to the course's webpage and navigate down to Project 1. And then the next thing, if you don't already have a public-private key pair set up and uploaded to GitHub, you'll want to do that now. What that does is it lets you interact with GitHub without having to put your password in all the time. And since you'll be doing a lot of GitHub and a lot of programming between now and the time you graduate, you might as well take a few minutes now and get that set up and save you a lot of password typing over the next 2 or 3, 4 years. And so if you don't know how to do that, this link here will take you to a video to show you how to get that all set up. Once you get that set up, then what you want to do is follow this link here to the GitHub Classroom page. If you're not already logged into GitHub, you'll probably get redirected to a login page. Once you do that, you'll end up at a page that looks something like this that asks you to accept the assignment. So when you click the Accept the Assignment button, what will happen is GitHub will create a new repository for you to do the project in. Now you notice it says it might take a couple of minutes. So, take a deep breath and then refresh the page. And what you'll see is the URL for your personal repo for this project. So if we follow that, you're looking at a standard GitHub repository page with all of the starter code for the project in it. So then what you do next is you clone the repository so you have a local workspace. So under this green code button, what you want is the SSH URL. Now you could use the HTTPS URL, but that's the one that'll make you log in all the time. So now that you have a public-private key pair, it's a lot easier just to use the SSH URL. So I'll put that on my clipboard and then come back over to my terminal. And then the command is git clone, and then I will paste that URL in there, and I'll get a local copy of the assignment code. Now we can see all of the files from the repo, the library, the source, the test. And so I could at this point just do this assignment using the command line and a simple text editor like VI, right? I could go into the source directory and run VI. And there's the code, and I could edit the code and do the project that way. However, just about any time somebody in the professional world writes code, they are using a nicer IDE. Those IDEs have all sorts of tools that make it easier and faster to write code, and now is the perfect time to start learning that. If you invest some time learning a good IDE now, then you get to benefit from that as you finish your assignments and all of your other courses while you finish your degree here at Grand Valley. Now, my preferred IDE is Visual Studio Code. I find that it's fairly easy to use and it feels fairly lightweight. I used IntelliJ for many years and it was my favorite IDE for many years, but I never got fully comfortable with it. I always felt I was on the verge of screwing my project up beyond repair because there were so many things going on that I didn't understand. And it also weighed very heavy on my computer. It was always using up a lot of RAM. It was always making the fans run. And so a few years ago, a friend introduced me to Visual Studio Code, and that seemed to really address most of those concerns. However, if you're already using IntelliJ and you like it and want to continue using it, feel free. Just realize that if things get messed up, there's not a whole lot I can do to help you because, like I said, that IntelliJ has confused me for many years. But for those of you who do want to use IntelliJ, let me show you how to set this project up. So what you do is start by launching IntelliJ and go to New Project. So you would do a Java project here. SDK doesn't matter a whole lot. And then give the project's location as the name of the folder that was just created when you clone the repo. So let's take a quick peek over here to make sure we get it right. Mine is simple date Kermis Z. And what it will do is it will build the project right on top of that code. It'll add the project files around the code. So you can see the source and we can see the tests. Now there's a couple of things we need to do. First, notice that that test folder is in gray. So we need to tell the project that our test files are there. So we right click on the name of the project here, go down to Open Module Settings, click on Sources, click on Test, and then click this green test folder up here. So we should see that the source folder is in blue, the test folder is in green, and then click Apply and OK. Now let's open up that test file. And you'll notice that the JUnit stuff is all highlighted in red here. The reason for that is that the JUnit jar files have not yet been brought into the project. That's a quirk I keep running into when I try to use IntelliJ in classroom projects. So here's the way I found to fix that quickly. So I'm going to go to one of these methods, and then I'm going to go to Code, Generate, Test, and I'm not actually going to finish this out, but notice right here in that second line, it says the JUnit 5 library is not found in this module. That's what's causing all of the errors. So I'm just going to hit Fix. And so that will tie in all of the JUnit stuff. And at this point, I'm just going to hit Cancel. I don't actually want to create any tests. The tests are already there. So now when I go back to the 163 test, that red is replaced with a nice friendly shade of yellow, and I can actually run the test. Like if I come over here to this green arrow on the side, I can run the test for not a leap year, and I can see that it passed. If I run the test for is leap year, that one failed. Of course it failed because the code isn't implemented yet. But at this point, everything should be tied together and you should be all set to finish writing your tests and then implementing the main source code so that those tests pass. So once you're confident you've written enough tests and all of your tests pass, it's time to commit your code to GitHub and run the automated tests. Now IntelliJ has a way to do that built right into IntelliJ. That's fine if you want to use it. I've never really done that. So I'm going to show you what I do. I go down to the terminal and I just submit my code from the terminal. So let's say I've made a change. How about changing this to return year mod 4 equals 0. That should make a few more tests pass. And then I'll come down here and do git add, git commit, and git push. And what that does is send my changes up to GitHub. So now I can come back to the browser. Okay, so now you can see we have 2 commits here, and that there were changes made to the source directory 3 minutes ago. That's what we just pushed. So now we want to run the automated test. So to do that, you hit the Actions button, and then the GitHub Classroom Workflow button, and then go to Run Workflows, and then assuming you haven't changed your branch, you just hit the Run Workflow. And it may take 3 or 4 seconds, but eventually you should see that that workflow is being processed. It's downloading the code it needs to download, compiling your code, and it will run the tests. Now, normally what you would do at this point is just wait for that yellow dot to turn red or green, but I'm going to play a bit and we can watch it run. And there you can see the tests that are passing and failing. And there are a lot of them. So this text scrolling by isn't going to make a whole lot of sense, and it's not supposed to. The automated tests are just a thumbs up or a thumbs down. And if your tests pass and these tests fail, then there's something missing in your tests, and we need to work on figuring out what that is. This isn't going to tell you. Now, the reason you have to launch these tests by hand is so that I can tell if you decide to beat on the autograder. So what I've seen students do before is just do commit after commit after commit, just hoping that the test will pass. And that's not what we're trying to teach in this course. So you need to be judicious when you're running those automated tests. And if I see a lot of reruns of the automated tests without any updates to your test files, then I'll know you're not following the directions. If you run into any trouble, please let me know by posting to Piazza, and I'll get back to you as soon as possible if one of your classmates doesn't get back to you first. Just remember, my ability to fix weird things in IntelliJ is limited, but I'll see what I can do. Have fun.